Hi students, Mrs. Keller here with a video about graphing the sine function. So we'll start off with some axes here. The x, or the theta axis actually in this case, is labeled here with degrees across it, and then our y-axis is labeled with at least a half and one, and I'm going to include over here a unit circle just for us to reference as we go through this. So when we're thinking about angles in standard position, recall that we have our initial side along the positive x-axis, and the sine of any angle is the y-coordinate. And so as we go around here and talk about the different angles, we're going to be thinking about the y-coordinate of all those points. So if we start here at 0 degrees, the y-coordinate of this point right here is 0. And so we'll go ahead and graph at 0 degrees. The y is 0. If we come up here to 30 degrees, the y-coordinate was 1/2, if you recall. And so if we go to 30 degrees, we can plot 1/2. As we continue going around, here's the square root of 2 over 2, which is approximately right here. And so we'll graph that one at 45 degrees. At 60 degrees, we're at the square root of 3 over 2, which is right here. And then when we get to 90 degrees, we're at 1, or our maximum value here. As we continue going around the unit circle, we'll keep adding these points. Once we get back to 180 degrees in the y direction, we're at 0 again. So you'll see we're back here. And then we'll just keep going around the unit circle, filling in all of those points there. Move myself out of the way so you can see the whole sine function. So if I were to take a moment and connect all of those dots, we see we have our sine wave, or our sine curve here. And this curve is going to continue on from negative infinity to infinity, because I can keep going around and around and around the unit circle. And you'll notice, so that's our domain, negative infinity to infinity. The range is going to be from -1 to +1, because even though the more times we go around and around, we're still going to be staying between -1 and +1. We're never going to get any further away from the x-axis. Here you can see that our points along here correspond to our distance in the y direction, because sine is always the y value. And so all of these points here for this first half of our circle correspond here. And then likewise, when we are on the second half of the circle from 180 degrees all the way around to 360, we were down here. Now I've just gone ahead and changed the angle values from degrees into radians. And radians is really the more useful angle measure that you're going to see from here on out in math classes. And so we're going to predominantly be working with radians. So I've basically just changed the theta axis here into radians. So you'll notice we start again with 0 radians. Halfway around is pi radians, and we're right here. And then all the way at the end is 2 pi radians. Now this is a lot of points that we just graphed and plotted to find this curve. When I ask you to graph the sine function, I'm not going to require you to give me that many points. I'm only going to require you to give me 5 points, and I'll kind of talk you through that here in just a second. So let's look at this right here. So we're going to start off. One thing to note about the sine function is that it always starts and ends on the midline. And so without any other transformations happening right now, our midline is this x-axis, or the theta axis. And so we're going to start here at 0 radians, and our sine is at 0. And then one complete time around is 2 pi, and so we're going to end here. So we start and we end on the midline. There's a cool trick to remember for graphing this, and that is that halfway between, we're at the midline. Halfway between these first 2 points, we reach our maximum. And halfway between these 2 points, we reach our minimum. So you can see right here, this is our sine curve. And you're only required to graph these 5 points for one complete cycle. Let's go ahead and graph another cycle in this backwards direction, negative angles. So the period length for the regular sine function is 2 pi. So I'm going to start here at negative 2 pi, and I end here at 0. Play the game of halves. Halfway between, we cross the midline. Halfway between these first 2 points, we reach our maximum. Halfway between these two, we reach our minimum, and then sketch the curve. So here is an example of the sine function graphed from negative 2 pi all the way to 2 pi. So that sounds great, but what if we have some different amplitudes or different period lengths? How do we deal with that? So here's something good to put into your notes. If we have this equation, you'll notice we have y equals sine of theta, but now I've added in a couple of letters, a and b. A is going to represent the amplitude. So if this number is a 2, then it's going to be twice as tall. If this number is a 3, it will be 3 times as tall. If it's a half, it will be half as tall. Notice it says the absolute value here, because if A is actually less than 0 or a negative number, it causes a vertical reflection. We'll talk about that in a minute. B represents the number of cycles that will occur within 2 pi. So depending on what this number is here for B, that's going to tell you how many times that sine function is going to cycle through within 2 pi. So the period length, if you're ever trying to figure out the period length from looking at the equation, you just take 2 pi divided by B, and that will tell you how long each period is. And if you know the period, but you're trying to figure out B to write the equation, for example, you take 2 pi divided by the period, and that will give you that B value. So let's look at a graph that has these features. So here's our regular graphed in red sine function. And now let's graph this one in purple. So the only difference here is that there's a 3 in front of the sine of theta. And so that means that the amplitude of this graph is going to be 3. So if you recall, amplitude is variation from the midline. So how far does the graph vary away from that midline? We haven't changed anything with the period length, so we know we're going to start and end on the midline, and our period length is 2 pi. We play the game of halves again. Halfway between, we cross the midline again. Now, halfway between these first two, we reach our maximum. Now, because the amplitude is 3, the maximum is going to now be up here at 3 instead of at 1. And then, let me move myself out of the way. Then, when we come between these 2 points, our minimum is going to be down here at negative 3. And so now we can sketch that curve, and you'll see that it has stretched the graph by 3, by a factor of 3. We can do the same thing coming back here, fill in these points. Halfway between, we hit the maximum. Halfway between the second two, we hit the minimum, and sketch the curve. So you can see the difference between the regular sine function and then this sine function that has an amplitude of 3. It has stretched it away. The total height, notice, from negative 3 to 3 is 6. Amplitude is always half the height. Let's look at another example. So here I've left the regular sine function still graphed, so we can see how that relates. And this time I have a number in front of the theta. This tells me that there would be 2 complete cycles from 0 to 2 pi, which means the period length is going to just be pi this time, because I would take, to find the period, it's 2 pi divided by b, and since b is 2, 2 pi divided by 2 is just pi. So I'm going to draw my sine function playing the game of halves again. I start and I end on the midline. So now my period length is only pi, so that's my ending value for 1 complete cycle. Halfway between, I'm going to cross the midline. Halfway between my first 2 points, I reach my maximum. Halfway between the second 2, I reach the minimum. And now I can sketch the curve. And you can see how that basically has shrunk that graph horizontally, and so that it has only 1 cycle here within pi. And if we were to continue on, you would see we would reach 2 cycles within 2 pi. Let's go ahead and do one backwards. So from negative pi and end here, halfway, cross the midline, halfway between the first 2 maximum, halfway between the second 2 minimum, and sketch the curve. So I've gone ahead and drawn 2 complete cycles of this curve. Now let's talk about what if I have a negative sign of theta here. So this basically just means it is a vertical reflection. So the amplitude hasn't changed, the period length hasn't changed. I will still start and end on the midline. Halfway through, I'm still at the midline. This time, halfway between my first 2 points, I'm not going to be at the maximum, but instead I will be reflected and be at the minimum. Between the second 2 set of points, I will be at the maximum because it is just basically reflected over the x-axis. I can do the same thing coming back in this direction as well and sketch the curve. So you can see that this graph is just reflected over the x-axis. I hope this helps you graph the sine function. Remember, you only need 5 points per cycle as you're graphing, and good luck. Let me know if you have any questions. Thanks.